It's fast, it's flexible, and it's powerful. No, we're not talking about me. We're talking about regular expressions in Python. Regular expressions, or regex in Python, is extremely powerful and fast and useful. Now, this video is going to be a little long, and it's probably going to be a little daunting. But don't let that dissuade you from learning it. I will tell you that even experienced programmers have to go back and look at regex one more time when they're going to do it. It's not something that is easy to commit to memory, and it's just something you need to learn how it works. And in reality, when you get ready to use regex in a program, you will most likely go back and review the syntax. Regex is pretty similar across multiple languages, but every language, every computer language kind of does it a little differently syntax-wise, but it is a concept that transfers to all programming languages, which is, well, I won't say all, but many modern programming languages, which is nice. But before we dive too deep, I just wanted to take a moment and tell you, if you've made it this far, we're pretty far into the lessons now, and I just have to commend you for not giving up yet. And I hope you never do, because learning programming is hard. And I would say the average person by this point would have already quit, but you haven't. Stick with it, and especially after this video, if you feel like maybe programming isn't for you, don't let that be the case. This is something that is difficult to learn and difficult to remember. For some people it sticks, and for some it doesn't. That's okay. I'm one of those people that regex doesn't stick. I know how it works, and when I need to do it, I have to go look and see what the syntax is for the language I'm in, and I have to work on it. I have to sit there for a second and really relearn it every time practically that I use it. But it is super powerful and super useful, so it's something you want to have in your toolbox when you're writing programs. So without further ado, let's move on down to the right hand corner and let's jump in. So before we start actually defining what regex is, we're going to use an example from the book. We're following Automate the Boring Stuff, and this is chapter 7. In chapter 7, we have an example of how you might find if a string has a phone number in it, or if a string is a phone number, without using regex. And that's what we're looking at here. And it's a lot of code. If we just scroll down, it starts on line 3 all the way down to line 29. Okay, and the idea is pretty simple. If the text isn't 12 characters, so we're looking for a phone number with the area code and dashes between it. So that would be 12 characters. Then it's not a phone number. We're going to say it's not a phone number. Then we check the first 3. If they're numbers, or if they're not numbers, then it's not a phone number. Then the 4th character at the 3rd index, if it's a dash, we're good. If it's not a dash, this isn't a phone number with dashes in it. Then we check the next 3, right? So at this point, we've got the area code, dash, and now we're looking for the next 3 characters. So indexes 4 through 7. If that is not a number, then it's not a phone number. Then finally, we check the 7th index. That should be a dash, because now we're going to get the last 4 after this. If it's not a dash, that's also false. And then finally, we get the last 4. And if that last 4 numbers are not numbers, then false. So then finally we return true if all of those things didn't flag off and have us return false. And if we run this, you can see down at the bottom we have, is this number here a phone number? And then we call the function and pass in that phone number. And then we also pass in moshi moshi. And so we know that's not a phone number, and we know that this is. So let's see what our function does. Simple enough. I mean, it works, but we have 36 lines of code here. If you minus the 3 that are, or I guess 37 lines of code just to do that. And that's kind of cumbersome, honestly, and it's not very flexible. What if there are parentheses, or the number doesn't have dashes in it, but it's still there? It's very difficult to write all that out in code, and your code would just get longer and longer. So we need something else. We need regular expressions. So I have another example here of actually using regular expressions. Now, before you use regular expressions, or regex, you have to import the RE module from Python. RE stands for regular expressions, and for the duration of this video, I will just say regex. That's what everybody calls it. But if you search anything online, you're going to search regex. But regex just stands for regular expressions. I call it regex. Some people say regex. It doesn't matter. But the idea is less words, less syllables. Okay, so the RE module, when you import it, has methods that you can use. So, the regex library has these methods you can use. And if you look at each one, they're all different in their own ways. So the re.search method searches the entire string that you pass to it for a match of a regex pattern, which we're going to talk about. What is a pattern? The match method looks for a pattern at the beginning of the string. So the search will look anywhere in the string. Match, it has to be from the beginning of the string. And then the find all method finds all non-overlapping matches of a pattern. So that kind of points out, if you didn't already think about it with search, search is only going to find the first match of a pattern in a string. Find all will find all the matches. So think about if you had like the word cat in a sentence and you were searching for it, but then you had it later in the sentence as well, it will only find the first instance of cat in the sentence. With search, find all would find both instances. Okay, so what is regex and how do we use it? Now I'm going to show you a simple way of using it right now, and at the end of the video I'm going to show you a way that you can write regex in Python that's more efficient, especially if you plan on using regex, the pattern that you define, over and over. And it has to do with using a method called compile. But for now, we're not going to do that because it's just easier to see the pattern, I think, when it's on its own in a string like this, rather than in a function call. So first of all, right off the bat, you probably notice we have the R. And if you remember, that is for a raw string. Remember that raw strings don't have to have, you don't have to escape backslashes in a raw string. All of the characters that you would normally put in a string in Python that you might have to escape, you don't have to escape here. So it's just telling Python, I just want a string with these characters in it. Don't try to interpret anything in this string as anything else except the character I type. And that's useful because regular expressions, which I said I wasn't going to say again, regex has backslashes all in it. And it would be super annoying. You know, if I didn't have this raw string, I would have to escape each one of these backslashes. And it's just not necessary if you just use a raw string. But that is something that will get you. So first pro tip, make sure you use a raw string with regex, or you're going to get weird errors and you're not going to know why, and it's because you didn't use a raw string. Remember to use a raw string. Okay, so we've got this pattern, but we still haven't talked about what it is. Now, I just want to show you, this is more of an example, and we're going to dive in deeper on how you write these out. But this is an example to show you how easy it is to use regex, and this isn't even the most optimal way to write this out, but just for the sake of showing you. /d just means any number 0 through 9, right? So my pattern is any number, any number, any number, dash, any number, any number, any number, dash, and then any number 4 times. So I write that pattern out, and I use regular expressions, re dot search, the search method, and I pass in to that function call, that's not a function, the method call, some parameters. I'm passing in the pattern, which we've defined here, and I'm passing in the string I want to search. Okay, so I search it, and that returns a regex object. And if I want to get it's a match. If it gets a match, it will return a match. That's what it's called. If it doesn't find anything, if it doesn't find this pattern I'm looking for, maybe because there's no phone number in the sentence, in the string, then it will return none. So it's kind of useful because what I can do is I can search some string for a pattern, and then I know that if it didn't find it, my variable is going to be set to none. So I can use that variable name in a conditional statement. And I can say if, I purposely created this variable name so that it reads nicely, found phone number. So if found phone number, then print out the number found. And notice, I have to add this extra method on here called group. Group gets the actual string that the regex found. If I were to just, so if I run this, do you want to continue? Oh, I have further stuff down here. Forgot about that. Yeah, so phone number found 41555 blah blah blah. It found the number. Really cool, really fast. But if I didn't use this group method and I just printed, it prints out this match object. Not super easy to read, not useful really at all, except that it is a value. So because it is a value, it is true. So that's one of those things in programming that's kind of nice. Because it returns none, I know that if I'm searching for something that doesn't exist, this will be none. Thus, it will be false. If it has a value, then it's true. So if you found something, now I know I can come in here and call group. If I tried to call group on this search and this search returned none, it would give me an error because you can't call this method. This is a method for the match object. So you have to check first that basically the object exists. And probably an even better way you could check would be, if I check the type of this object is a match object. But for the sake of this simplicity, this works perfectly fine. So let's look at another example. Let's say we're asking the user, do you want to continue, yes or no? So think about this. They could type out all caps yes and all these different variations, right here. There's so many variations of what they could type instead of just exactly what you told them to. And wouldn't it be nice if it was easy to check that? And as long as they type a Y followed by something, if they type out yep or uppercase Y, lowercase y, it really doesn't matter. As long as they type out a Y, then we're happy. So one way you could do that, this is coding. There's a lot of different ways you can do stuff, but just to show you how you would do it with a regular expression or regex, I define my pattern. It's a raw string, and the only thing in the pattern is the letter Y. This looks way more confusing, but you can also just type in regular characters you want to find. You're searching for a pattern, and in my case, I'm just searching for the letter Y. And as long as I find the letter Y, then I'm happy. So let's see how that actually works. I print out, and I actually show you what happens when you print out. Well, let me just run it and I'll show you. So if I type out Y, and I kind of already showed you this, but the value returned from the search method is this match object. But just like I was saying, you can use the fact that it did return something in a conditional statement. In this case, I didn't even reassign to a variable. Doesn't matter. I can just call that method. If it returns something, then I know we're good. If it returns nothing, then I know that it didn't find it. So watch. If I run again and I say no, value returned from the search method is none because it didn't find Y. And so this was false. So it didn't print out. User wants to continue. Now you might be looking at this line of code and thinking, what the heck is going on here? Well, I'm just printing and I put a comma, and inside of a print statement, you can separate values by a comma. But what is going on here? We didn't talk about this. So actually, when you call these methods on the regex object, you can pass in, they allow you to pass in one more parameter. And there's several options, but the only one we're really going to talk about is ignore case. So if you type, a comma, and then you put in re dot ignore case, all caps, then it won't matter. So you'll notice I only put a lowercase y here. So how would it work, if I typed in uppercase Y? It still works. It was still true here that it found the Y because it's case insensitive. And just to show you that it works with other options, if I type yes with a bunch of other stuff after it, it still works because it found that Y. So it makes your program very robust, and it actually makes it a little bit more user friendly because they're able to just, type out a word that is logical to them, and that they're saying yeah. Okay, moving on. So in regex, you can use a sequence of characters to define a search pattern. For example, if we want to find all the instances of the word cat, then our regex pattern in the word, our regex pattern is the word cat. And that's kind of what we're talking about. And notice I'm doing this on purpose. I switch between single and double just because I want to drive home that it doesn't matter. But you can do either one. Single or double quote, not a big difference. So we have this text, the cat sat on the mat, and my pattern is cat, so I'm looking for cat word, and I use the re object, find all, pass in the pattern and in the text, and let's print the match. And it prints out cat. Now find all is different than search. Find all returns a list of the matches found, so you don't have to use that group method. Special characters in regex serve as building blocks to create versatile patterns. The dot character matches any single character except the new line. So I have a sentence, the bat went splat on the mat. And I have a pattern, and it just says a dot, so it could be any one character, right? Just one, but it can be any character. And then the two letters AT. So now our patterns are getting a little bit, you're starting to see like, oh, okay, I can see, because now I can actually search for many different things as long as there's a single character and it's followed by AT. And we're going to use find all, so it's going to return bat, lat, and mat. Bat, there's a single character. There's AT again. It only gets that first one it finds. It doesn't matter if there's letters before it. Our pattern was a single character followed by AT, and then mat. So if we run that, bat, lat, mat. Makes sense. Okay, so now let me give you all the details and try to overwhelm you as much as possible. No, I'm just kidding. It seems like this is the part I was talking about where it seems overwhelming, and this is the part where I'm talking about I have to come and read the definitions when I'm writing out regex. It's just the way it works. So don't feel discouraged if you're like, I don't know how I'm ever supposed to remember all these things. Just know of the ideas and what your possibilities are, and you'll be fine. So there's this idea of character classes, and that allows you to match specific sets of characters. So if you put in square brackets lowercase a through lowercase z, then that will match any lowercase character. Before we were just typing out single characters like y or cat, and it would match for those characters together. But if you put the square brackets, you're saying, hey, for this range here, a through z, it could be any of those, and that's fine. Okay, and then uppercase A through uppercase Z, same thing. You can actually do different ranges in the same square brackets. So this would be any lowercase and any uppercase is fine. /D is any number 0 through 9. I think of it like is digit. Slash uppercase D is it's just the opposite. It's any character that's not a digit. So think of it like not digit. /W, think of it like word. It's any letter, numeric, digit, or underscore character. /caps W is any character that's not a letter. Think of it as not a word. It's not a letter, numeric, digit, or underscore. /S is a white space, basically. Space, tab, new line. \caps S is any character that is not a space. So it's not white space. Okay. So there's that's character classes, and you can define your own. We'll look at that in a minute too. But there's also the idea of quantifiers. So these are all just matching a single character. How do I specify how many instances of a character or character group that I want? You've got the asterisk, which means you can match either none or as many times as there are. Plus sign means you got to have at least one of the pattern I put. And it could be more than one, but it has to be at least one. And the question mark is either it's there one time or it's not there. If you wanted to detect any of these characters as part of your text pattern, you need to escape them with a \, okay? Because these are all special characters that have value. They mean something to the regex program. So if you're going to use any of these, you want to detect a $, for example, you need to use the \ to escape it. You don't have to escape the \ itself. If you use a raw string, well, actually you do, because the \ itself is special. So just make sure you use these escape characters if you're going to use any of these characters, and you'll be fine. Okay, so let's say we have the text, room 101, :200 guests, right? And we want to find, we're trying to, use our program to extract out the room number and the number of guests. We want to drop all the noise because we're trying to do something with a program and we want the numbers, right? Well, first off, probably the easiest way, just create a raw string, say that it has to be a number, and it has to be plus, it has to just be at least one number, right? So as long as it's one, it'll pick that up. And we're using find all. So there's two matches here. Well, if we're reading through the string, wait till we read a number. We hit 1, oh, that's a number. And we've got a plus sign, so as long as we've got 1, how many more do we got? 1, 0, 1, oh, colon, that's not a number, okay. So our first match is 101. Then it keeps reading, it hits a 2. It's like, hey, that's a number, 0 through 9. Okay, I've got a plus sign, so I gotta get at least 1, but I can get as many that come after that as I need. So 0, 0, space, that's not a number. Okay, so the second match is 200. So if you run this, you get a list, right? Remember that find all returns a list, and it's just a list of the two matches. If we ran to find caps A through caps Z, the range on this, well, the only caps letter in here is R. So it's just going to return R. We're using find all again. If we ran with lowercase z or A through Z, then it's going to find every, okay, because look, this is what I'm trying to show you. Up here I did a plus. So that means, you know, you've got to have at least one of whatever I defined in the pattern, which this case was just 0 through 9. But as long as the number, the thing that comes after it is still a number, it's going to be part of that same match, that same group, same item. But because down here I didn't do that, I just said A through Z, then each time it detects a lowercase letter, well, that's a separate match. That's why there's a comma. And it found all the lowercase letters. Now if I say A through Z caps, and I put the plus, now we're actually going to find words because it'll read the sentence until it hits a space, because a space isn't one of those letters, and it'll stop and it'll say, okay, well, room is 1 because it has caps R, which is allowed, right? And it has OOM, that's allowed because of this. So it'll pick up room, it'll read the numbers, those aren't allowed in the match, so it's not going to pick them up. It'll hit guest or G here, and it'll pick up the whole word guest. So you could extract out the two words if you wanted to. You can also define your own custom patterns, and that's what I was telling you about earlier. So all you have to do is write out the square brackets, and instead of writing out A-Z or something like that, you just type out the letters you want. Don't put a comma. Don't put anything between them. Just write out the letters you want. Notice, like right here, I didn't put a comma between these two or anything like that. Just put what you want, and it will know. I want A, E, I, O, U. Try to match any one of those. Because they're in the square brackets, it knows that this is a character class, okay? It's not going to try to find A, E, I, O, U all together. It would if I didn't have the square brackets, okay? But the square brackets tell it, okay, you're telling me that these are different characters you're looking for, and as long as it matches one of these, we're good. So when I run that pattern on the text, it finds all the vowels, and they're separate, because again, we don't have a plus or anything like that. So if we had a plus, it would actually look, and it would only return, let's see, room, so the two O's, and UE, because there's a vowel followed by a vowel. It'd be kind of interesting to run on maybe a book or something, if you ever wanted to. And then the last thing I wanted to show you on this one is if you create a custom character class, you can create the idea of a negative class. So, whatever you define in here, I want the opposite of that. So if you put this little caret at the front, which is on the 6 on your keyboard, it should be. So shift 6, and then you should get the caret. So if I type out A-E-I-O-U, I'm saying I don't want those, don't match those. Don't match any white space, that's what \s is if you remember. and don't match any numbers. So if I run that, then I get everything that's not a IOU, not a space, not white space, and it's not a number, which happens to be all these characters. So all the consonants and symbols, basically. All right, let's keep going. We're trucking along. We're 30 minutes in. I know it's long. There's just so much here to learn, and so I wanted to give you the most robust video I could on this. Okay, so we're going to keep trucking. Let's say we have this text called, "We have you booked for room 101, 200 guests." I can pass in the pattern. I wanted to show you this. You can type in a regular string like room and then use \d, 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 right? And if you run that, it will match room 101. Now, there's this idea that's pretty sweet. Instead of having to write \d 3 times, you can just put curly braces and put the number of times you want that thing to repeat. So if I put \d with a 3, then I will get 3 times. And I don't think I showed, yeah, that's coming up. Okay. So if I run that, we'll get the same answer. What I do? Oh, here we go. I was like, it didn't match the same. Why? Okay. Oh man. Okay, so there you go. Room \d with a 3 matches the same exact thing as the first one, right? Now, if we type out and we say \d, and okay, now we're using some of these quantifiers. We said plus sign here, which means at least one number, followed by however many numbers. Then at some point, any character, as many times as we need. So basically, I want you to find room, then a space, then a number followed by any numbers, and then basically I don't really care what comes after it. Give me all of it except a new line. That's what the dot does. It matches everything except a new line. The star says for the dot, match as many times as you need, or none, which matches basically to the end of the string, as we see here. So it finds room 101 and then it just gets the rest of the string. So with the curly braces, you have some options. You could type in the number of times you want the pattern to match, like we did with 3. If you put a comma and then a 3, you're saying that match 0 to 3 times. If you put a 3 and then a comma, you're saying match at least 3 times, all the way up until the end of the string. I don't care. As many times as you match, you match. 3, 5 would say match 3 to 5 matches, and it will always match the largest amount possible. So if you think about, like, if I was doing \d and I said 3 to 5, and there was a number with 5 digits, if you think about it, technically 3 digits would match, 4 digits would match, 5 digits would match. The group that with 5, it's always going to be greedy, is what we call it. If you don't want it to be greedy and you want it to match on the smallest number first, so if you wanted it to match, like if I had a number like 1005 and I did 3, 5 question mark, then I could have it actually match 1005, and it would only match 100. It would only show the number 100 because it would pick out the first 3 that match and stop. That question mark is what makes it always match the smallest amount of matches possible. Okay, and these are just nuances that you probably won't need that often, but they're nice to have in your hip pocket. So let's say we have the text. We have you booked for the room 101, 200 guests, and we use the pattern. Room, we have any number at least one time, right? And then we have any character. It could not be anything after that, or at least 2 characters. So basically any 2 characters, up to any 2 characters. Then some numbers. Now if we do that, what do we match? We get room, which makes sense, and space. And then we get any number of times, at least once, which is 101. Then we have the period with the curly braces, which says any character at least or not up to 2 times. It could be none because there's nothing in front of the comma. Which in this case we do have 2 characters. We have a colon and a space. And then after that, we're just like any number at least 1 time up to however many there are. And notice it doesn't pick up the guess or exclamation point because the last thing in this pattern is a number. So it picks room 101, colon, space, 200. Now groups allow you to isolate parts of the match for extraction or manipulation. Parentheses are used to define these groups. And when you call find all, when groups are used, normally you get a list, but when you use parentheses, you get a list of tuples. Basically, it allows you to break out the different values you're matching on. So each of your list items is now a tuple of the different groups you created in your match. So for example, again, we had the same sentence and we match on room, but instead this time we put parentheses around the decimal here, or the \d plus sign, which we know will match 101, just like it has been. But we put parentheses around it. So 101 is grouped to itself. Then we have the extra noise, right? The colon and the space that we don't really care about. And then we group, but we know they are there in the text, so we kind of have to account for them in our pattern. And then we group the other number. So in this way, we were able to extract 101 and 200. So the room 101, 200 as the guess, and using find all right here, it returns a list. Now our list has 1 item in it because this pattern did not repeat again in the sentence. If somewhere in the sentence we had another one, which we're going to see, then it would return 2 items in the list. But this time it returned 1 item, and that item was a tuple. That's why there's parentheses inside of the square brackets. And the tuple are the 2 groups. So 101 is the first item in the tuple. It's the first thing we wrapped in parentheses. 200 is the second item in the tuple. It's the second thing we wrapped in parentheses in the pattern. Now, just to show you what it'd be like if you had multiple matches for your pattern of room, some numbers, 2, whatever, and then some numbers. Here's our first match. Right? And here's our second match. When I run that code, it's the same pattern. There's nothing different between the patterns. It's just a sentence that has 2 matches in it. When it returns a list of tuples. So first tuple is 101, 200. Second tuple is 230, 10. 230, 10. Pretty cool. All right, we're going to keep trucking. We're almost there. We're almost done. Okay, so just one thing to note. In the beginning I talked about the match method. The match method starts from the beginning of the string. So you might be thinking, okay, if I already see I'm reading, I've got this caret that says, start of string. How does that work with the match method? You don't actually need it for the match method. The match method will search for the pattern starting from the beginning of the string as it is. But it's just good to know. And if you want to be explicit with your pattern, and make sure that your pattern doesn't break if someone were to change the method on you later if they were to change your code. So yeah, these are special characters in the regex that allow you to say, in my pattern, I want to start from the beginning of the string, so there should be no text before my match. Same thing with the $, except for the end of the string. So let's say we have this list of different strings, right? And I want to loop through and find the string that starts with check-in. I don't really care what comes after it. I'm trying to find the check-in string, right? So I loop through the list, And for each sentence I match on that sentence, I use my pattern. My pattern is pretty simple. The caret tells it that I want to start from the beginning, so does using the match method. But the caret is explicitly saying I want to start from the beginning of the string. The very beginning of the string should start with the words check-in, and then I don't really care what follows that. And if there is a match, so it's going to return a match object, right? If there's a match object, then print out the match.group. So print out the text that matched. And if you run that, I get that sentence. Check-in time is at 2 p.m. So this could be a list of 1,000 sentences and you're looking for a specific thing. It could be a log file that has every 5th log, but sometimes it's the 6th log, or sometimes it's the 7th log or line, sometimes it's the 10th line. And so it's hard. You can't like programmatically say like, oh, check every 5th line in this log file and that's the line you want. Sometimes you have to search for it, right? Sometimes you have to write a program that says, read through this log file and find the lines that start with, firewall blocked, blah, blah, blah. That's the lines I want, and regex is super powerful for that and exactly what you should use. Okay, now let's actually look at how do we make this faster. I told you I'd tell you about it, and you stuck around for 41 minutes, so kudos to you. I promise I tried to make this as fast as I could, but if you go too fast on this, I feel like it'll go right over your head, because it practically goes right over mine. But, so here's the cool trick. Let's say we have the same text, same exact problem as before. We're trying to find check-in time. Now, instead of just writing out a raw string and calling it our pattern, and then calling re.search, we're going to do something different. So instead of writing out our pattern like this, we're going to do pattern equals, and we're going to call re.compile. So we're compiling the regex right now. And we're just going to do the same thing as before. We're going to write out our pattern. But instead of just creating a string with the pattern in it like we did before, we're putting it inside of a method call to compile. Okay? And then just like before, we loop through each of the sentences. And instead of calling re.match and then we pass in the pattern in the sentence we want to use, we don't have to have the pattern again because it's compiled, it's built in now. We have this object that just knows I'm checking for the word check-in. I don't need you to tell me, I already know. Just tell me what to check. And that's what this is. We type out our variable name pattern. We use just like we were before, but with the match, we say .match, but now all we have to do is pass in sentence, the sentence we want to check. Now, if I run that, it will match just like before. But this is much, much better than writing out the pattern like we were before. If you're going to be reusing the regex over and over, because you've compiled the regex, and basically that just means that some stuff behind the scenes got set up so that it could check the sentence for you. And it's kind of, imagine there's like, it costs money to do that every time you compile. And because you did it once here, like maybe you do it you check that regex pattern 5,000 times in a for loop instead of 3 times, maybe it's 5,000 times. You only have to pay to compile it once. That's the idea. Now, if you do it the way we were doing it before, where you just use re.match and you put the pattern in, you have to pay to compile it every single iteration of the for loop. So if you're iterating 5,000 times or maybe 5 million times, it costs a lot. You're paying all this extra money to compile when you don't need to. All you have to do is compile it beforehand. So that's the trick. I didn't start by showing you that because it's already complicated enough, and I felt like it'd be easier to just let's just talk about the pattern first. And then let's talk about how you can throw it into compile and make it faster. And if you're only going to run like one check on something, then it doesn't really matter because either way you have to pay to compile, right? the idea is that when you're doing it a bunch of times, that's where you get the best bang for your buck. Okay, and now I just want to show you one cool example of how you might check for an email address. Okay, so we're just checking if it's a valid email address here, right? We have some function called check email and then a couple calls down here to the function. And notice that we pass in this ignore case in the call to compile. Now, in the past, one of these examples, I showed you ignore case, right? And you put that when you're calling the search method. And you could have done that on any of these. When I'm calling find all with even on the RE object, I could just say, hey, I don't care. I don't care about case. That's where you would pass it in when you're doing the find all. But when you do the compilation first like this, you always have to pass in the re.ignore case up here when you compile, because remember, that's when you're paying. You're paying right then and there, get everything set up. So you have to tell it when you're paying how you want it set up. So hopefully that analogy makes sense, but the idea is you gotta give it everything it needs to get set up when you call compile. If you're not compiling, then yeah, you can pass it in when you're matching, like right here. You could call it, because you're gonna pay right here, so you can tell it how to set it up right here. But when you're compiling, you gotta pay right now. So you gotta tell it everything it needs to know to get set up. But once we get that set up, let's take a look at what actually is happening here. So we're saying start of the sentence. So whatever you pass in from the very start, it has to match this. Any number, any letter, any number, 0 through 9, any lowercase letter, right? Any number 0 through 9, period, underscore, or a dash. Plus, so it could be any of these characters at least one time, up to however many times, doesn't matter. Followed by an @ sign, sounds like an email address to me. And then followed by A through Z, lowercase, 0 through 9, period, underscore, dash, at least one time, up to however many times. Followed by a period. Notice how we had to escape the period, because we know the period stands for something else, stands for any character, but we actually want to find a period in our pattern, so we escape it. Followed by a through Z at least 2 times, and then end of the string. And then we pass in we do comma to pass in one more argument, and we pass in re.ignore case. So I don't have to say in here A-Z. I don't have to do that because I'm already telling it just ignore case. Okay, so it simplifies my pattern a little bit. And now that my pattern is compiled, I can say, hey, pattern.match email address. So the email address that gets passed to it, whatever the text is, it could be like hello world. It's going to check it, and it ain't going to pass because it won't match this crazy pattern. And if it is, if it returns an object, a match object, then return the email address plus, is a valid email. Otherwise, return the email address plus is a invalid email. So if we run this, kind of see it in action. Good examples of the emails based on the parameters we gave, right? So you can have underscore, you can have a period, same thing in the second part, like that's fine, followed by a dot, and then at least 2 letters, so .com, now those are all good. Bad examples. This one has a exclamation point. We didn't say that was allowed, so it told us that's not a valid email. We put a star, also not a character that we allowed. Test pound, not a character we didn't allow. Test at example.x. We said that the last bit there was A through Z at least 2 times. So because it doesn't have at least one more character, also doesn't match. So we hit this else where we return invalid email. So that is the end. We went for quite a long time, 50 minutes of just pure joy. I'm happy you made it this far. If you haven't already watched it, I think now might be a good time to bring up why you're doomed to learn Python. If you're feeling like you might be doomed, go and watch my latest video, Why You're Doomed to Learn Python, and hopefully that helps explain why you're doomed. But I appreciate your time. Hopefully this video was helpful, and I look forward to seeing you in the next one. Thank you.